Hello, here's the difference between scalars and vectors. A scalar describes just magnitude. So this size, the size of this pen, is about 5.5 inches. So it just describes a single quantity. A vector describes two quantities, both the size and the direction. So in a scalar quantity, this would just be 5.5 inches, for example. The direction of the pen does not matter, but if it's a vector, then it does matter. So if this is north, south, east, and west, then this 5.5 inches is facing north. So that is a vector. If I tilt it slightly by a degree, then it's a different vector, even though it retains the same magnitude. So magnitude and direction, those are what goes into vectors. When you get into multiple vectors, you could add them, you could subtract them, etc. Now, if you move a vector across, like on a page or like this, as if you could visualize them with a pen, you can move vectors back and forth, up and down, diagonal, as long as they keep the same, as long as they retain the same quantity, the same magnitude and direction. So it's perfectly alright if you just move a vector from here to here. Is it the same magnitude? Yes, about 5.5 inches. Is it the same direction? Yes. So that's why when you add vectors, when you add vectors, you need to place them in a head to toe or a head to foot. There's different ways to describe it, manner. Then you could move vectors such that the head of the first vector is at the foot of the second vector. So that's why it's perfectly alright to move vectors. You could even move it like this. You're still at a head-to-toe manner. So that's just the very, very, very basics of scalars and vectors. Again, scalars is one quantity, just magnitude, the size of it. The vector is two quantities, which is magnitude and the direction. Like speed is a scalar because you could say that you're going like 50 miles an hour, but it doesn't tell you like what direction you're going. If you're going at a constant direction, like let's say 100 kilometers an hour due north, then that's a vector quantity because you have both magnitude and you have the direction, so both magnitude and direction. If you change your velocity, even if you remain constant speed, but you turn, because if you turn, you change the direction, therefore you change the vector. And if you're describing a velocity, if you're going the same, like 5.5 miles an hour, for example, and you just turned, and you're now going 5.5 miles this way, 5.5 miles this way, then you just accelerated, basically. You just change your velocity. And whether you increase your speed, decrease your speed, or change directions, or a combination of two or three, then that changes the vector, and you are accelerating. So basically that's the basic difference. So thank you everyone. I'm not going to ask you to like or subscribe. I'm passionately doing these videos from my heart. You could if you want to. I'm not calling any of my videos perfect or ideal, relatively speaking. Besides, this is merely a fraction of a 0.25% of all the myriad of videos out there concerning this subject, including videos with more easy-to-help animation and explanation. I'm simply one voice out of many, and thank you very much for your time for watching.